Hi, welcome to the class. Today we will understand one more measuring instrument, and the name of the measuring instrument which we are going to study today is the screw gauge. Okay, so this is a screw gauge. So let us first understand what are the important components of this screw gauge. So you can see a screw kind of thing here, right? So that is why we call it screw gauge, and there are two scales. I'll show it to you. One is this, which we call the main scale, and one scale is this, which we call the circular scale, because it is this circular scale is there on a cylinder, right? This is the cylinder, and this is what we call ratchet, right? Ratchet we call it. This is a cylinder, main scale, circular scale, and here you have a screw. So these are the important components of this screw gauge. Now why are we studying this screw gauge? Because if we want to measure the thickness of a paper or the thickness of a wire, then that thickness I cannot measure using a measuring scale or a vernier caliper, because the thickness is very small as compared to the least count of a measuring scale or a vernier caliper. So the least count, what is the least count of this instrument? What was the least count of vernier caliper? Think about it. So the least count of this device is 0.01 millimeter, 0.01 millimeter, which will be equal to 0.001 centimeter. So that is why this device can be used to measure the thickness of the paper, right? So now look here, this zero, look here, this zero of the main scale, the zero of the main scale coincides with the zero of the circular scale. Right now you could see that the zero of the main scale, the reading of the zero of the main scale. So this is the zero of the main scale. It is coinciding with the zero of this circular scale. So right now when these two readings are coinciding with each other, that is what we call that the screw gauge is error free. So there is no error in this scale, in this screw gauge. This particular screw gauge, it does not have any error, as the zero of the main scale coincides with the zero of the circular scale, right? But what if they are not coinciding? In that case, what will happen? So if I tell you about this, there can be two kinds of zero error. One can be positive zero error and the other can be negative zero error. In case of positive error, you will see, in case of positive error, you will see, in case of positive error, you will see that the zero of the circular scale, this is the zero of the circular scale, and this is the zero of the main scale. You could see this is the zero of the main scale. This is the zero of the main scale, and this is the zero of the circular scale. So in case of positive error, zero of the main scale will be above the zero of the circular scale. So this zero of the main scale, this is the zero of the main scale, and it is above the zero of the circular scale. So this screw gauge has a positive zero error. Now how do we calculate that positive zero error in this case? So to calculate the positive zero error, we have to find the division of the circular scale, which is coinciding with the zero of the main scale. So division of the circular scale, you have to find the division of the circular scale which is coinciding with the zero of the main scale. You have to find that division. So division of the circular scale coinciding with the zero of the main scale, you have to find out. So this is 10, you could see this is 10. So this is 10, you could see this number is 10, and I'll find out for you 10, and then okay, this is 0, 0. So it is around 7. So 7th reading of the circular scale, 7th division of the circular scale is coinciding with the 0 of the main scale. Seventh division of the circular scale is coinciding with the 0 of the main scale. So you will write 7 into LC, the least count, that is 0.001 centimeter. So the positive zero error of this scale is plus 0.007 centimeter. Why? Because seventh division of the circular scale is coinciding with the 0 of the main scale. So you will multiply that number, that division, by the least count, and least count is 0.001 centimeter, and therefore it has plus 0.007 positive zero error, right? So this was in case of positive zero error, what will happen? 0 of the circular scale will be below to the 0 of the main scale, right? So positive zero error, how to identify, we know. How to calculate, we know. Now coming to the negative zero error. So in case of negative zero error, what will happen, you think? So in the positive zero error, the 0 of the circular scale reading was coming below the 0 of the main scale. So in this case, what will happen? Obviously it will 0 of the circular scale reading will come above the 0 of the main scale reading. So let us have a look here. So just wait for a few seconds, it will, yeah. So you see, this is the 0 of the circular scale, so it will be above to the 0 of, yeah. So basically this is the 0. Basically this is the 0 of the main scale reading. Here it is, this is the 0 of the main scale reading, and circular scale reading 0 is here. It means 0 of the circular scale reading is above. Who's above? The main scale reading. So here is the 0 of the main scale reading, and 0 of the circular scale reading is above the main scale reading, the 0 of the main scale reading, and therefore it has a negative zero error. Now how to calculate the negative zero error? Again you have to find the number of divisions of the circular scale which is coinciding with the 0. So around 85th division of the circular scale reading. So 85th division, this is 80, this is 90, and in between 85th division is coinciding with the 0 of the main scale reading. So 85th division is the division which is coinciding with the 0 of the main scale reading. So how do we calculate this negative zero error? So in this case, what we will do, the number of divisions in the circular scale are 100. Number of division in the circular scale are 100. Number of division in the circular scale reading are 100. Which division is coinciding? Which circular division is coinciding with the 0 of the main scale reading? 85th. So what you will do? 100 minus 85. What is 100? Number of division in the circular scale reading 100. What is 85? Division of the circular scale reading coinciding with the 0 of the main scale reading. So 100 minus 85 into LC. So that is 15 into LC. So 15 into LC means 0.001 centimeter. So that would be how much? 0.15 centimeter, and that will be in minus. Why minus? Because it is negative zero error, right? Now how do we correct the value? We have to correct the value when we are taking the readings. Whenever we are measuring the thickness of the paper or the thickness of a wire, we have to correct the reading. So correct reading will be observed reading, whatever reading you are observing, right? So if you have a positive error, then whatever reading your reading is coming with that positive error screw gauge, that you have to write, that is your observed reading. If it is if your screw gauge is having a negative zero error, then whatever reading will come, that will be observed reading. So in that observed reading, you will do observed reading minus zero error, whatever kind of zero error you are having. So suppose you are having a positive zero error, so it will be observed reading minus positive zero error. Now positive zero error will be plus, so it will come with the sign. Suppose it is having negative zero error, in that case what will happen? So it will be observed reading minus, and then minus will come. Why minus? This minus is coming because it is a negative zero error. So whatever is the sign of that particular zero error, that will come into play. So observed reading minus zero error with sign, right? So positive zero error will be plus and negative zero error will be minus. So this was about the introduction of this device, screw gauge, and in the next class we will do a measurement, we'll try to take the thickness of a wire using screw gauge, right? Thank you.